Okay, so this should be a review of the layers of the Earth. It shouldn't take too long, so just bear with me for a moment. This gives you a cut through of exactly what it looks like. This is to scale with your kilometers and your thickness. The 4 layers. The first layer you have is the crust. This is the layer that you live on and is the most widely studied and understood. The mantle is much hotter and has the ability to flow. This is your mantle. You have your upper and your lower mantle. The outer core and the inner core are even hotter with pressure so great if you were to travel there, you'd be squeezed into a ball smaller than a marble at the center of the Earth, which is kind of crazy. So for the crust, it's like the skin of an apple. It's very thin in comparison to the other 3 layers. The crust is only about 3 to 5 miles um, thick under the continents. The lithosphere is where your plates and where your plate tectonics start to shift, so you need to keep that in mind. So the crust of the Earth is broken into many pieces called plates. These plates float on the soft, semi-rigid asthenosphere. It's a mouthful to say, but keep it in mind. The asthenosphere is the semi-rigid part of the middle mantle that flows like hot asphalt under a heavy weight. So you have your lithosphere and then you have your asthenosphere. The lithosphere is the crust on the upper layer of the mantle. Together make up a zone of rigid, brittle rocks called the lithosphere. So you have your lithosphere and then your asthenosphere. Within the crust, it's composed of 2 rocks. The continental crust is mostly granite. The oceanic crust is basalt. Basalt is much denser than the granite. Because of this, the less dense continents ride on the denser oceanic plates. The mantle is the largest layer of the Earth. The middle mantle is composed of a very hot, dense rock that flows like asphalt under a heavy weight. We've already talked about that. The movement of the middle mantle is the reason that the crustal plates of the Earth move. So that's going to be within your asthenosphere. Convection currents. Convection currents is something that we're going to do a lab on, but I'm going to go ahead and give you the background behind it. The middle mantle flows because of the convection currents. They're caused by a very hot material at the deepest part of the mantle rising and then cooling and sinking again. Repeating this cycle over and over. You can see your arrows right here that are completing the cycle and repeating it over and over again. The next time you heat anything like soup or water in a pan, you can watch the convection currents move in the liquid. When the convection currents flow in the asthenosphere, they also move the crust. So you have your crust moving to the right, you have your heat source, and then you have your currents. When the convection currents flow in the asthenosphere, they also move the crust. The crust gets a free ride with these currents. See right here? Like the cork in this illustration. If you try this at home, do not get your face too close to the boiling water. For your outer core, the core of the Earth is like a ball of very hot metal. The outer core, right here, is so hot that the metals in it are all in the liquid state. The outer core is composed of the melted metal of nickel and iron. So right here, this yellow area. Your inner core of the Earth has temperatures and pressures so great that the metals are squeezed together and are not able to move about like a liquid, but are forced to vibrate in place like a solid. So we have this kind of metalloid type feel, you know, like on your periodic table you have the metalloids where they have traits of a metal and they also have traits of a non-metal. Okay, so here's a bonus for you. I want you to write this down on your paper. Have we ever seen part of the mantle? And I want you to explain and verify your answer.